What you guys really need is a railing along here, because by the time you look at those lights once or twice, you completely lose the edge of the, I can't see that. So if you see me go splat, call 911, then take pictures. So that's actually different when you're kayaking. So I'm a whitewater kayaker, and when you go through a particularly gnarly rapid, you always say, take pictures first, then throw rope, because you want to have your picture taken while you're making some heroic whitewater move that's epic. And so it's important to get the order of picture and help correct. Welcome to Developing Software Development. As always, there's these little things that get in the way of progress. As you've noticed, I'm something of a pacer. I like to walk around. The thought of standing, first of all, it bothers me to stand higher than you. And when I get behind here, I feel like I should be preaching. So I did some testing. I got a little clicker, and I tested it in my office with my setup, with one minor exception. I did not have a VGA display to test with. All my displays are HDMI. So I get here, and guess what? My clicker doesn't work in this configuration anymore. So I will do what I can. I will be coming down to the floor a lot, hopefully without falling. And we'll look at developing software development. I've been involved in the business for some time. And as my mom says, the biggest room in the world is the room for improvement. I've been, like I said, 34 years in the business. And I think there is definite room for improvement in software development. I consider myself a developer. I'm from that side of the family. Started as a control systems engineer, got into software. I've enjoyed it immensely. And I'm noticing that we're still having a lot of the same problems today that we had 34 years ago when I started in the business. And I'm wondering, what can we do about that? So just to give some context and some framing, how old am I? Fortran 4 was still in use. I was paid to write software in Fortran 4. Of course, Fortran 77 was the official Fortran at the time, and it was 7 years old. So things have shifted a lot. We are solving much more complex problems today than we tried to solve in 1984. And we are solving them in ways, I'm thinking of like containers, the cloud, and these sorts of things. We're solving these problems in ways that weren't even conceived of 34 years ago. Oops, double tapped. Oh no, 2 lines. A 300 baud modem, but at least it was a direct line. It wasn't an audio coupled modem. Let's see, what else? Oh yeah, I was manufacturing, so we had 100 acres of manufacturing under roof, and the VAXs, the PDPs, and the 1123s, if you added everything all together, had less memory and CPU than what's on my phone today. It was before the internet. That's how long ago it was. We had, ARPANET was around, and for those of you who had a great dial-up modem, you could contact me at 71614, 71717. That actually wasn't CompuServe based in Columbus? Yeah. That's how long ago it was. Some things that were around then that are still around that shouldn't be. The iron triangle. That's where the manager gets to decide the scope, the resources in terms of money, and the functionality to be delivered. Of course, the only dependent variable left is quality, and that never works well. The Man-Month. Fred Brooks, wrote a great book called The Mythical Man-Month. and talks about some of the fallacies of the Man-Month. The great line being, you cannot make a baby in 1 month by assigning 9 different women to the task. It's now back at us as part of the Agile world in terms of the universal 2-point story. This is where companies with multiple teams on multiple projects want to have one way to calibrate all of their teams so they can get predictability, which they can't, and possibly rank people and teams against each other. I once had a director say, well, Don, it's a friendly competition. I don't know that there is such a thing as a friendly competition. I've never seen it. If I'm in a competition, watch out, I'm there to win. Fungibility. This shows itself by the use of resource. When you hear managers talk about, well, I need 2 more resources for this team on this project, they are thinking in terms of fungibility. One programmer is equal to another programmer. I can pull one out, put one in, I lose nothing. In terms of gears in a motor, maybe. In terms of software developers, absolutely not. And work elements are equal. So this speaks somewhat to Taylorism, that if we can just make everything all the same, then we can engineer this. Joe had a session this morning on human systems and talked about organic agile. You have to understand that the context, so back up a little bit. In real estate, they say the 3 most important things are location, location, and location. In systems thinking, the 3 most important things are context, context, and context. So we'll never be in a situation where all the work elements, nor are all the software developers, interchangeable and equal. The myth of efficiency, loading people so that they're always busy. And for some reason, many managers think that fingers on keyboard is work. Actually, the work is the thinking that happens before the fingers hit the keyboard. So when you overload somebody, you're going to start to see diminishing returns. Best practices, we'll talk about these in a bit. More transformations, more changes. So when I got started, the big thing was business process reengineering. BPR, this is back in the late 80s, early 90s. And people would come up and say, oh, look at how FedEx is doing it. We must be like FedEx. And they'd try to be like FedEx and everything would crash and burn. The company might go out of business. Another example of this would be forced ranking from GE, Jack Welch days. That, oh, this is how GE does it and they're making money. We should do it this way too. They're getting the solutions without understanding the problem they're trying to solve and the context in which they're trying to solve it. And last so to wrap up best practices, they may exist, but be careful if you ever try to grab one and use it. It might bite you. And one right way. One right way comes from our education, especially from engineers, mathematicians. You know, it's simple. You either get the answer right or not. In software development, any reasonable programmer can show you 2 to 3 ways to solve any given problem. The question is, what is best for this situation? So these are ideas that I think should die, but haven't yet. I'll see what I can do to help them die over the next 10, 15 years as I wrap down my career. At this point in time, the room should be filled. We should have, 15, 20 CEOs, 100 managers, and then developers and doers, the makers. Given the size of the audience, I don't think we're going to split that way. What I'd like you to do is, if you're sitting by yourself, if you're not in a group at a table of at least 5, let's take a couple minutes and come on in and join a table that has at least 5, no more than 8. And that's how we'll start building into our groups for the next few activities. All right, thank you for doing the move. So let's talk about our time together real quick. We're going to go cover what is software development, what activities do we get involved with while we're doing software development, in the process of software development, in the creation of client value. Then we'll look at problems, what gets in the way of this. We'll look at some heuristics. We'll design some solutions, and then we'll have a quick wrap up at the end. Yeah, we're on a good time. So, software development. In your table groups, individually, take 2 minutes, and I'll let you know when 2 minutes are up. Think about the activities that you are involved with in software development. What do you do? What activities do you do? What activities are around you that impact what you do? So, 2 minutes. What's involved with software development? And this is, we're going to do talking at the table. So this is just think for yourself, think by yourself, make notes if you've got something on which to make notes. And then we'll go to a table discussion in just a minute. So still at the tables, in your tables as a group, have a conversation. What sorts of things did you come up with? Share your ideas at the table. And then what we'll do is we'll go through the tables real quick and jot down some of the things that you've identified that happened during software development. Well, that's just useless, isn't it? Let me see if I can change that maybe. Anyway, what we're going to do is build the slide deck. So we are actually building the slide deck. It'll go to Faye, and she will be able to put it up on the download site in a couple weeks. So what you do here today will be reflected in the final slide deck. Are we ready to report out? All right, so what I'd like to do is, starting with this table, whatever your favorite topic is, your favorite activity is, let me know, and then we'll just go from there to here, and then start working down that side. So, the table to the front left, my front left.
Making coffee.
Making coffee. Next group. A little louder, please. Requirement gathering. Can I change that to gathering requirements? Okay. Changes. This table.
Customer interactions or communication.
Table and back. Ooh, we've got microphones going around. Thank you.
Going with context switching.
Context switching.
Who would like to speak? Coding. Developing.
Hands on the keyboard. Love it. I mean, think about it. It's almost godlike. You take stuff in your head and you make it manifest in real time in the world. It's powerful. And it's also artistic because you're creating bringing head stuff into the world. So I really enjoy developing. Next table.
Software design.
I'm sorry?
Software design. Design software.
Designing software. Thank you. Design the software.
Are you guys playing? You don't have to. If you're just participating, just observing, would you like to chime in? You don't have to.
Estimating. All right, so here are some things that we do in software development. Along with making the coffee is trying to get the coffee consumed. Drink the coffee before it burns. You can tell somebody's been having a long, hard night when you come into the office in the morning and you smell burnt coffee. So pizza should be on that list somewhere, it seems like. All right, so this is what I've got so far. I'm trying to learn. So this is Don's view of the world. It is by no means complete. And so you're helping me complete my map of the world. Thank you. And my little laser doesn't show up. So basically in the top left we have coding, which involves technical practices, essential difficulties, and accidental difficulties. If you've read the No Silver Bullet by Fred Brooks, he talks about those topics. The most interesting for me is complexity. Essential difficulty, complexity, is the idea that every time you write a piece of software, you're doing something new and novel. And it's an act of exploration, it's an act of creation, and how you can expect somebody to tell how long it's going to take them to do something they've never done before is a very interesting question. So below that we have some product area. We've got learning, social difficulties, organizational structure, people difficulties, and work models and metaphors. So this will be in the slide deck. This is sort of what I'm working with right now, trying to understand why is it difficult? What problems do we have developing software? Why are we still having the problems today that we had back in the mid-'80s? In some cases, it's because we're doing bigger, better, more complex things. And I think at some level, it's because we have yet to come to grips with the fact that software development is a very broad area. So when we think of software development, quite often we think of coding. But in reality, we've got the product stuff that some of the tables mentioned. We've got team stuff, learning. The stuff I learned in college, the languages I learned in college, I don't use. Probably very few people use the languages they learned in college. So we have to keep learning. Knowledge has a half-life, probably 5 years or less, because the stuff that we're going to try to solve in 5 years, those languages are just starting to emerge today. So if you're still programming with and working with stuff you learned 10 years ago, your knowledge is eroding in the marketplace. And it's necessary to keep learning. All right. Problems. What gets in the way of software development? And again, this is a table activity. In your table, take a couple minutes. Do some, once again, individual work and think, what gets in the way of developing software? And make some notes, and then we'll have another table conversation and report out. Okay, in your table, 4 minutes. Share your ideas about what gets in the way of software development. And pick one item that you want to look at a little bit more. One item per table, maybe two. So at a table, talk about what gets in the way of software development, and put one or two on separate index cards. So you've got index cards and Sharpies. Put the what gets in the way on an index card. Using the Sharpie, please write legibly. Do all the tables have at least one what gets in the way on an index card? I'm seeing heads bobbing. Heads bobbing. That was a poorly phrased question. We'll try it this way. Never mind. Let's go. So let's start over here this time. Far back corner over there. What gets in the way of software development?
Scope creep.
Scope creep.
Do you want more?
Hold on to that one. You went first, so you win. If somebody else had scope creep as their what gets in the way? They have to go to their number 2 card. Yep, let's just work through the tables.
Other priorities?
Something priorities, help me.
Other priorities.
Other priorities, okay. If everything's a number 1 priority, nothing's a number 1 priority.
Spokesperson for this team?
Dependencies.
Dependencies,
People, which is ego, skills.
people, ego / skills. Next table.
We have knowledge gap.
Knowledge gap.
Production issues.
Production issues.
Unmade decisions. Unmade decisions.
Unmade
Decisions waiting.
decisions. Okay. In other words, decisions that get made and then changed again.
Or just ones that are hanging
Microphone.
or ones that are just hanging around. Can we use this software? And we wait and we wait and we wait for someone to say yes or no. Or can we get a new team member? Or can we use this architecture? Or can we whatever?
So decisions, questions that are asked but never answered.
Yep.
All right, thank you.
We have interruptions.
Interruptions. Look at that, your stuff is already in the workshop. So what we're going to talk about now is something I call heuristics. It's really hard to come up with a process to solve all problems or a process to do all of anything. Instead, I like to have a handful of heuristics, rules of thumbs, things that I go back to time and time again that provide guidance and direction for the actual processes and activities that I do. One of these is the Cynefin model. This comes from the work of Dave Snowden. This is referenced in the, I have a slide all the way at the back that says references, and so I link to his website. Dave's work suggests that there are essentially 4 domains in which we can operate, one of which is the obvious. So if you look at this, from bottom, so as you're looking at it from the bottom right corner to the bottom left corner, you go from the obvious, complicated, complex, and chaotic. Obvious and complicated are ordered systems. The advantage of an ordered system is you have cause and effect. You can determine cause and effect and know it prior to starting to work on the problem. So in the obvious domain, you have best practices. You know what to do. Everybody knows what to do. There is no variation. You have rigid constraints. You must do it this way. In that area, in that domain, in that space, you can have a best practice. The problem with that is if you're doing all your work in the obvious domain, somebody else is making all the money because those problems have been solved. We know how to solve those. We've been making money off of them. Accounting software. I would not write an accounting software right now because it's been solved. It's been solved by many people many times over. There's no reason to do it. You're going to lose money. Complicated domain, which is just above it, talks about good practices. There's great ideas, and once again, since it's in the ordered domain, it can be solved. The question becomes, can you solve it? So quite often, we end up with people, we call them consultants, who provide services and knowledge to help us solve the problems in the complicated domain. So we've gone from best practices to good practices. When we go to this side of the graphic, we now are in the complex space. Complex space and chaos are unordered systems. So in the case of an unordered system, cause and effect can only be determined retrospectively. You cannot start with, this is what I'm going to do, and know for certain that this is what's going to happen. So here we have the domain of emergent practices. So here we probe, sense, and respond. Do a little something, see what comes back to us, and then decide what we're going to do next. So agile transformations would fall at least in the complex domain, because you cannot guarantee what's going to happen when you take a little step, much less when you take a big step. So this is where we have emerging practices, and once again, Joe this morning talked about human systems. It's my fundamental philosophy is, until proven otherwise, anything that happens in software development, I start in the complex domain. Just because it's most likely the right place for it to be, and if I can prove for myself that it is actually an ordered system, then I can work back into complex, complicated, and perhaps even hit obvious. And then finally, the chaotic space. This is the case you don't know what you're doing, so you just act, sense, and respond. It's the absence of constraints. You don't know what's going on, but you've got to do something. So this is sort of abstract, and the next slide is kind of overloaded. So I took several different documents and combined them and put them together. So again, you have obvious, complicated, complex, chaotic, and disorder. Disorder is when you don't know what domain you're in. Now, the classic case of disorder is when you're actually in a complex domain and you're trying to solve the problem using best practices. So here you have the instance where we're using something which is meant to be used in an ordered system. We're applying it to an unordered system, and it looks like it goes along just fine until we're like 2 weeks from delivery, and now we say, oops, we can't make delivery. So in an agile system, done properly, using an iterative incremental delivery method, this should be less of a problem. You should know you're not going to make your delivery long before 2 weeks out. Sometimes it does work that way, sometimes it doesn't. So that's what happens is you come right at the edge and then you fall over into chaos. And so I'm going to RASP, running around screaming in panic is the process. I learned that this morning in Joe's session. So it's a new process for me. Running around, screaming in panic. And that's what happens. And then things kind of calm down and we go back to another system where we're going, okay, now it's another, we got 6 months extension from the client, and now we go through the same process, and then again we end up in the RASP. In the grasp of the RASP. How about that one? Okay, so that's another view of Cynefin. What I did do is I stole some stuff from a lady by the name of Liz Keogh. You can know her as Lunavore, perhaps. And if you take a look at the 4 domains, you'll see that I have an example from each, or a programming example for each domain. Something from our domain and experience to help kind of anchor what it means to be in that domain. So, programming a turtle, that's where you say, tell the turtle, go forward 2 steps, turn left, go forward 2 steps, turn left, go forward 2 steps, turn left, go forward 2 steps, and great, you've just drawn a square on your screen. That's obvious. CRUD is complicated, but it's fairly well understood. You can find somebody to help you learn CRUD if you cannot do it yourself. Web technologies tend to be kind of complex, and what is it? Defects released to production. We had somebody mention defects earlier, production issues. So that creates chaos because you don't know how it got in there, you don't know what it's doing, you know it's not doing what it should, and what's going to break when I touch it to fix it. So these are the sorts of anchors we have in the Cynefin domains for software development. All right, so can we get the handouts out? I'm sorry, I asked them to do this later, but it turns out I'd like them out now. So each table will get 2 or 3 of these sheets of paper. So we'll be able to share. And what it is one side is one set of heuristics, which is the Cynefin, my version of Cynefin. So as you look at these, the next question we're going to ask is, you should be looking at a mind map that looks something like this. We're going to ask ourselves the question, so you came up with an issue, something that gets in the way of software development. Where does that fit? In which Cynefin domain does it fit? Because we'll solve these problems differently. So I kind of go like, yeah, we can buy this, why would we do it? Someone knows how to do this. Someday we'll understand what did this and what. So let's take, at the table, 3 minutes and take a look at the problem you picked as a table and tell me in which domain it resides. And once again, we'll go around the tables and do just a quick report out. How much time did I say? 3 minutes? 3 minutes.
Don, our group here is asking for a little more context as to what this exercise, what are we trying to solve? Could you?
We're not trying to solve anything yet. So the question is, so if we go back to the Cynefin domains, we use different techniques for solving the issues in the domains. Right now, all we're wondering is, in which domain do we think this issue falls?
That's it.
That's it.
Excellent. Thanks, sir.
You're welcome. And hold on to your thought, because what we're eventually going to get into and how are we going to solve this? That's coming. Let's go ahead and start at the back table over here this time. Okay. So I will make this all pretty and nice for the final version. Starting at the table back there, where do you think your problem, which domain?
Which one did we decide? Well, which domain did we have? Someone knows how to do this. Someone knows how to do this.
Someone knows how to do this. And what was the problem?
Lack of vision.
Lack of vision?
Yes.
All right, thank you.
Unmade decisions.
And that goes in which domain?
Complicated? Yeah. Complicated.
We had interruptions, and that would go under what or chaos?
And which one?
Interruptions.
And which domain does it fall in? Do they?
Chaos.
Chaos, interruptions. Thank you. Anywhere, pick a table.
We'll start here, work our way back.
All right. We had knowledge gaps, and we thought it could either be complex or complicated.
He's still typing. So our issue was people skill.
People skills?
Yeah, and it was somewhere between someday we'll understand and someone knows how to do it. And if you had to pick one, we'll go with someone knows how to do it.
All right. And you said knowledge gaps, correct? Skills. Skills gap. And I did get this correct. You think could be both between the two domains. Okay. Thank you.
We had dependencies, and we thought that sat somewhere between complex and complicated.
Thank you.
Yes, ours is other priorities. I think it's under someday we'll understand.
Thank you.
For scope creep, we thought it fell under chaos.
Scope creep. Thank you. Now what we want to do is take a look at another set of heuristics. I got these from the Groves method. It's a series of staged practices that help individuals, teams, and organizations learn in software development. It's grovesmethod.com. It's once again in the references. So as we look at solving problems, what are some good rules? So first of all, let's figure out which domain we're working in, because that impacts the activities, whether we probe, sense, respond, act, sense, respond, sense, categorize, act, whatever. We should know or have an idea in which domain we're working, because that governs our activities. The next thing are 4 heuristics. 1, organic, not robotic. And so we want to be enabling, not controlling. We value, and this we value, it goes back to the manifesto, people and relations over static rules. We want to influence the culture, and I'll let you go ahead and read. So, organic, not robotic. We want loops, not lines. We want to loop back. We want to do feedback. We want to take information from the environment, let it govern our decisions, and then as we take actions, see how that goes back out into the environment and what comes back to us. So we're looking for feedback. Systems thinking falls into this category, such as causal loop diagrams, diagrams of effect, circle of causes, those sorts of diagrams. Small batches, batch size and happiness are inverse. The larger your batch size, the unhappier you're going to be. The smaller your batch size, the happier you're going to be, because you're going to be into this feedback loop much quicker. Fail fast, recover fast. So for those of you who've already read the backside of the paper, these are the 4 things we're going through right now. And be intentional, not accidental, and use actuals, not proxies. So instead of worrying about what is the team's velocity, it's how many user stories have they actually completed. Over time, that will be sufficient. Demonstrate running tested features, not PowerPoint displays. As a coach, when I was coaching, it always hurt me when I would see teams doing PowerPoint displays of the work they had completed instead of actually showing the running tested features, and I encourage them to not do that. So 4 more sets of heuristics of how we should look at a problem and how we can act to influence our decision-making as we try to develop software development. All right, so we've been through heuristics, solutions. This is where we're going to design a solution. So let's see, how are we doing on time? Yeah, we got time. So let's take 10 minutes. So each table has a particular issue they came up with. Take 10 minutes at your table, have a conversation, and design a solution. Now, when we think about solutions, I've already talked about feedback, so we want fast feedback. It should be inexpensive. The more people you have to ask for money to do something, the more likely it is that you're not going to be able to do it. So inexpensive, it also correlates with no permission needed. Find something you can do that you don't have to ask for permission. When I was younger, I would be known occasionally to say things like, it's easier to get forgiveness than it is permission. But I'm stepping back from that edge just a little bit as I've grown older and going, just pick something you don't need permission for. And it should be easy. And if you go down the list, you'll see it spells fine. Fast feedback, inexpensive, no permission needed, and easy. And this comes from the work that Esther Derby and I do in coaching beyond the team. So let's take 10 minutes and work on designing a solution. What is something that's simple, easy, and will give you fast feedback you don't have to ask for money or permission to do? And we'll report out in 10 minutes. We're at time. And so what I'd like to do is let's start with the back table with scope creep. And what are 2 or 3 things we can do, at least one, but maybe 2 or 3 things we can do to work on scope creep?
The most popular one was just say no. Beyond that, you can do more with understanding the full plan of the task at hand. Avoid gold plating.
All right.
Put in a good change management process. Those are really the good ones.
Management.
Nice job, guys.
So the other priorities table seems to have moved on to some other session. So other priorities. Real quick, let's brainstorm a couple things. So if we have multiple priorities coming at us, what are a couple of things we could do? Real quick, shout out. Ask what's more important.
Evaluating based on some kind of data thing like cost of delay or something, value add.
Thank you. Evaluate based on some data thing. Dependencies.
So there will be a couple of things like maybe task A is dependent on task B or vice versa.
Okay, I'm catching silverware clanging over there more than I'm hearing you, so please again.
Like there might be 3 tasks based off of A, B, C. B is dependent on A to complete, and maybe task C is dependent on B to complete.
Right.
That might be one example. The other example would be we are dependent on a resource from a team for which we are waiting on, maybe including the team member in our daily stand-up meetings to get the requirements from their team.
So I think I heard report out in stand-up meetings on status for like the dependent on something.
Yes.
And then there was something before that that I'd like to capture.
Or maybe the tasks, basically dependent on the other task that needs to
Okay.
be completed.
I'm going to say correctly if that's close enough. How about people skills or people?
This table?
Just to clarify, ours focus is skills.
Skills.
So
Okay.
our answer is knowledge share. That can come in the form of rotating paired programming opportunities, interactive learning such as, say, lynda.com, Pluralsight, Udemy, etc. Lunch and learn sessions, coding together, hiring the right people, and providing experience.
Do you have those written down?
Yes.
So I can get that list from you and update this later?
Sure.
Okay, thank you. Because you had a great list, and I want to capture that, but I just can't type that fast.
Understood.
So I'd like to get that list from you. Thank you. Knowledge gap?
So ours is very similar to the last one. So we had like pair programming, we had in-house training, consulting, and that kind of goes on a range from really cheap to more expensive. But then things like allocating time to learn during your sprints. Yeah.
Okay. And because if learning isn't on the board somewhere, if the company is not allocating time to learn and practice new skills, it's not going to happen. One of the things I've noticed is the retrospective, what are we going to improve over the next sprint? What are we going to work on? The teams that actually put it on their board and allocate time to it do much better than the teams who go, yeah, we're going to do this over the next sprint. And even if you assign somebody to remind them, or if a team member volunteers to remind the team that they said they were going to do this, it still generally doesn't happen because we're still too busy. I don't know if we're too busy. We're very busy creating new features. And like I said, it's magic. We take stuff in our heads and we make it exist in the world. And it's a very compelling thing to do, although it doesn't always work to our best advantage. Do you have the list also written down? Could you duplicate it on a card for me? Thank you. Production issues.
So this was a tough one because it falls in chaos. So we thought that the table thought that it's like a symptom, and we can target like pair programming and mob designing. Something like that, swarming on stories, so that that's the most inexpensive way to avoid production issues.
So did I hear smaller stories in there? No.
Yeah.
Okay. And what else? There was some other stuff that I didn't quite catch.
Pair programming.
Pair programming.
Mob designing, mob programming, swarming.
Is that close to correct?
Yeah. Yep.
Okay, thank you. Unmade decisions.
So we had a few. We could, first of all, measure the number of unmade decisions out there, then how long it took for decisions to get made, the average length of time. We could come up with a definition of done for decisions, and some heuristics around who can make what decisions. So teams can make these ones, and individuals can make these, maybe with budgets or whatever attached. And then a target for how we were going to change it. So maybe we could aim for, we want all of our decisions to be made in whatever, 24 hours, and the longest in 2 weeks or something, as an idea. But first, I guess, measure how many and how long, and then we could decide.
Yeah. All right. And interruptions.
We were talking about shielding the development team by having the product owner prioritize interruptions, or even just jokingly hide the development team so people can't interrupt them.
Yeah. So one of the practices in stage 1 of the GROWS method is team interruption protocol, so that you can say, okay, this is our agreement on interrupting, and go from there, inspect and adapt. So thank you for contributing to the session. I've got 4 questions. And so the questions are, what did you notice during the session, our time together? We're coming to a close. So what did you notice? What surprised you? What stood out as we were working through the process of Don's an old guy, to not all problems are equal, to hey, here's how we can solve some of our problems related to software development? And how does this session relate to what you do when you get back to the office? And what's one thing you're going to do different when you get back to the office on Friday, or Monday for those of us who are traveling on Friday? So let's take 5 minutes at the table, just discuss those. We'll do a quick report out, and then we'll go to questions. So let's go ahead and just get a quick report out from the tables. Hopefully everybody came up with one thing that they will do when they go back to the office. But for the sake of time, let's just have one per table, starting with the table in the back. One thing you'll do differently.
For notice, we said we noticed there's a lot of issues that can impact development. I don't know do you have the 4 questions?
Okay, the 4 questions. Yeah, I can go 4 questions.
And what surprised you? We had...
so I would like to, so in the interest of time...
Oh, just do one?
May we just do the one that says, what one thing will you do when you return to work?
Oh.
Just one thing you'll do when you return to work.
I think as a group we came up with this handout they had with the Cinefin and the heuristic chart, trying to understand where the issue falls to help
So did I
categorize
hear that understanding where the problem falls initially?
Yeah.
All right. Thank you.
Thank you.
Next table. Any table.
We said get more involvement from the users, like invite at least one member to the daily stand-ups.
And I will clean up the typos.
We got to know the better problem-solving approach, the way you categorize the chaotic, complicated, obvious, and the complex. So based on that, we can categorize our problems and we can try to solve it in a better way.
Okay, so
Yep.
categorize problems and respond to them appropriately.
Yep.
Next table.
For knowledge gap, we had try pair programming.
All right. Thank you.
I'm going to invite the stakeholders to come down, because that's a particular challenge in where I'm working at right now is the stakeholders are in a different physical building.
Thank you. Next table.
Get some data on unmade decisions.
In status reports,
make sure the management understands what decisions I'm waiting for.
All right.
We wanted to make sure we had slack time in the process.
I'm sorry, say it again?
Slack time, want to have slack in the process.
There's a book by Tom DeMarco called Slack. Excellent book. If you're in the case where you're the 100 to 110% allocated, and it does happen. I once worked with a guy who was assigned to 3 scrum teams, 50% each. So he's already at 150% load, plus he was borrowed from another team, domain area, and he had 3 projects in his domain area. So if you have a manager who's doing something like this, Slack is an excellent book to share with your managers. I'd like to thank you. We're at the end of developing software development. Do you have any questions for me?
What's the last great book you read?
The last great book I read was Helping by Edgar Schein. I'm a coach, or I have been a coach, and helping is something we all want to do. It's something that society expects us to do, but the way in which we offer help can determine whether or not it will be accepted and whether or not we will be able to build a great relationship. The book I just finished is Left of Bang, which is the Marine Corps Combat Hunter Guide. It's an interesting book. I'm trying to figure out how it relates to software development. Left of Bang. Left of Bang. It has to do with the fact that there's a bad event happens, that's the bang. Left of it is before it happens in time. So you want to be before the bang. In software development, it could be the project delivery. What can we find before the disaster happens that would let us know the disaster is on its way and allow us to mitigate the impact of what's happening? Another question?
Is that like predicting earthquakes and volcanoes?
I would suggest it's not quite as yeah, somewhat, but with enough practice and intuition, the Marine Corps has discovered that yes, people can detect unpleasant events before they happen. But it usually requires a lot of training and or a lot of time in living through bad events. So it's sort of in the same category as volcanoes and earthquakes. Thank you so much. Oh, and thank you to Mark and Brian, the volunteers who handed out stuff and carried microphones around for the workshop.